The drainage basin is the area of land around the river that is drained by the river and its tributaries. There are a couple of key words that you need to understand for this particular part of the specification. So you need to understand what a watershed is. A watershed is the area of high land forming the edge of a river basin. Up in the upper course of the river, we have our source, which is where a river begins, and the source flows to the mouth, which is where a river meets the sea. As the river flows from the source to the mouth, we see that there's a number of tributaries that join. A tributary is a small river or stream that joins a larger river. Our river channel is where our river flows, and we're going to be referring to a number of these key terms as we go through this presentation tonight. We're going to be looking at how a river changes from the source to the mouth, and we're going to be looking at how the upper, middle, and lower courses of the river change. And we're going to start by looking at our long profile. Now, our long profile is a line that represents the course of the river from the source to the mouth. And our long profile is split into 3 sections. We have the upper, the middle, and the lower course of the river. In the upper course, there is a steep gradient, and we are in what we would call a small stream stage. As we move downstream to the middle course of the river, it becomes less steep, and the gradient is gradually decreasing. Finally, in the lower course of our river, we see gentle slopes, and it becomes a lot more flat as we reach the mouth of our river. So as we can see, as we move further downstream, the height above sea level decreases. Now, when we're looking at our long profile and we see how the upper, middle, and lower courses of the river change, we can also compare that to our cross profile. Now, our cross profile represents a river from one side of the river to the other. Now, I like to remember this by thinking if we were standing in the middle of the river, okay, and we were looking at what we could see in the middle of the river, that is our cross profile. Okay, we don't really see this because we're not often standing in the river looking up towards the source or down towards the mouth. With the cross profile shows from one side of the river to the other, and we can also look at it from the upper, middle, and lower course. As you can see on the diagram, the shape of the river channel changes. In the upper course of the river, we see mainly a V shape. We see a V shape because the river is cutting downwards, okay? There are steep valley sides, the river is not too deep yet, and the channel is narrow. Here we are seeing mainly vertical erosion, or that downward erosion. It is this vertical erosion that helps to create our steep V-sided valleys, interlocking spurs, waterfalls, and gorges, which we're going to look at in a little bit more detail later on in this presentation. As we move to the middle course of the river, we begin to see a mix of what we call lateral and vertical erosion, which causes the channel to become wider, but also slightly deeper. This is because the river is holding more water. It's holding more water because it could be increased due to tributaries joining the river, increasing the overall volume of water. A larger river channel means there is less friction, so the water also flows much faster. Then as we move to the lower course of the river, it becomes wider and deeper again. The river has a high volume and a large discharge. The river channel is now deep and wide, and the landscape around it is mainly flat. Remember, if we compare it back to that long profile, the gradient is much flatter here. We have much less steep land, so the area around it is flat. However, as a river reaches the end of its journey, the energy levels are lower and deposition begins to take place. Our river changes down as it goes downstream because of 3 key processes. So there are 3 key river processes. We have erosion, transportation, and deposition. And these 3 key river processes help to shape the river. All 3 play an important part in shaping the surrounding landscape. Erosion is the process that wears away the riverbed and banks, and it breaks up the rocks that are carried by the river. And there are 4 types of erosion. There is hydraulic action. This is the sheer power and force of the water as it smashes against the river banks. Air becomes trapped in the rocks, in the cracks of the riverbed, and causes the rock to break apart. So we've got the sheer source of the water breaking it apart. Abrasion is when the pebbles grind along the riverbed bank and bed in a sandpapering effect. So I always like to think of that feel of sandpaper and how that sandpaper rubs and wears something down. That's the same process that's happening there with those rocks. Attrition is when rocks that the river is carrying, they sort of bang against each other, they knock against each other, and so they break apart, and they also become then smaller and much more rounded and much smoother as they kind of bang and against each other. And then we have solution, and solution is when the water dissolves certain types of rocks. So for example, limestone. As we move downstream, erosion decreases. Okay, because deposition becomes more and more important. We also have transportation. Transportation is the movement of materials from one place to another. There are four main types of transportation that you need to know. We have traction, which is where our large, heavy pebbles are rolled along the riverbed. This is the most common near the source of a river as the load is much larger. So we have sort of bigger boulders that are being moved and they're rolled along the river. Saltation is where pebbles are bounced along the riverbed, and this is most commonly as well near the source. So it's a hopping motion of pebbles. Suspension is when our lighter sediment is suspended. Okay, so if you think of suspension, if you think of being suspended in the air, okay, you'd be bouncing up and down if you were suspended in the air. Lighter sediment is suspended and is carried within the water, most commonly towards the middle and mouth of the river. And solution is the transport of dissolved chemicals. This varies along the river depending on the presence of the rocks. So it changes depending on what types of rocks are there. The bigger the material, the higher the rate of flow is needed. And transportation increases as we move downstream. The third process we have is deposition, and deposition is the leaving of material behind. The rate of deposition increases as we move downstream. When the river loses energy, it drops any of the material it has been carrying, and this is known as deposition. Now, there are certain factors that lead to deposition. So, for example, shallow water at the end of the river's journey, such as the river's mouth, and when the volume of the water decreases. As stated earlier, these three processes of erosion, transportation, and deposition impact the features we find in each course of the river. So in our upper course of the river, we will find V-shaped valleys, interlocking spurs, waterfalls, and gorges. And as the river erodes the landscape in the upper course, it winds and bends to avoid areas of more resistant rock. This creates our interlocking spurs, and they look a little bit like the interlocking parts of a zip. When a river runs over alternating layers of more resistant and less resistant rock, rapids and waterfalls may also form. A waterfall is a sudden drop along the river course, and it forms when there are horizontal bands of resistant rock or hard rock and positioned over exposed less resistant rock or softer rock. So the soft rock is eroded quicker than the hard rock, and this creates an overhang or a step. As erosion continues, the hard rock is undercut, forming an overhang. Abrasion and hydraulic action erode to create a plunge pool at the bottom of where the waterfall is being formed. Over time, this continues to get bigger. It's going to increase the size of the overhang until the hard rock is no longer supported. And because it's no longer supported, it just collapses. This process continues and the waterfall retreats upstream. As the waterfall continues to retreat upstream, a steep-sided valley is left where the waterfall once was, and we refer to this as a gorge. And this process continues to repeat and repeat itself. So in the upper course, the features we see are our V-shaped valleys, our interlocking spurs, and our waterfalls and our gorges. As we move to the middle course of the river, we start to see meanders, including our slip-off slopes and our river cliffs. So as you notice on our diagram here of our river meander, at Y we have a river cliff. Our river cliff is formed because the bank on the outside of the bend is being undercut by our lateral erosion. We also find here that we have our fastest current, and that current is helping to erode that river cliff. On the inside bend here, we have our slip-off slope, which is where sand and shingle have been deposited on the inside of the bed. We also have a much slower current. As we said earlier, that slower current is what causes that deposition because there's not enough velocity to carry that material any further. As the river makes its way to the middle course, it starts to gain more water, and so therefore it has more energy, and that lateral erosion starts to widen the river. When the river flows over flatter land, they begin to develop these large bends called meanders. As the river erodes laterally to the right side, then the left side, then the right side, then the left side, it forms large bends and horseshoe-like loops called meanders. So you can see that meander forming in that diagram there. The formation of meanders is due to both our deposition and our erosion. The force of the water erodes and undercuts the river bank here where we have our river cliff created. And on the inside of that bend where it's slower, material is deposited and there's more friction. And that's our slip-off slope. So what you need to be able to identify here, if you look at this image, you need to be able to identify our meanders. Okay, you need to be able to identify where we have river cliffs, okay, river cliffs, and where we have that deposition more on the inside. In the lower course, the river has a high, as we move to the lower course, we start to see floodplains, levees, and estuaries. Estuaries happen near the mouth of the river. In the lower course, the river has a high volume and a large discharge. The river channel is now deep and wide, and the landscape around it is flat. However, as a river reaches the end of its journey, energy levels are low and deposition takes place. It now has wide floodplains. So a floodplain is the area around a river that is covered in times of flood. Deltas are found at the mouth of large rivers, for example, the Mississippi River Delta, and it's formed when the river deposits its material faster than the sea can remove it. Floodplains form due to both erosion and deposition. Erosion removes any interlocking spurs, creating a wide flat area on either side of the river. So we have that wide flat area here on either side of our river. During a flood, material being carried by the river is deposited, and as the river loses its speed and energy, to transport materials. Over time, the height of the floodplain increases as material is deposited on either side. This then forms our levees. So we start to see a buildup of material that happens over time as the river floods. Now, floodplains are often left as agricultural land, as the area is very fertile because it's made up of alluvium, which is deposited silt from the river flooding. An estuary is where the river meets the sea. The river here is tidal, and when the sea retreats, the volume of the water in the estuary is reduced. When there is less water, the river deposits silt to form mudflats, which are an important habitat for wildlife. So now that we have a good understanding of how a river changes from the source to the mouth in the lower, middle, and upper course, let's take a look at some example questions that you might have to apply your knowledge to this particular section. So the first question to consider is where in the river's course would this image be taken, and what could you identify in this photograph if you were asked to annotate it? I'm going to give you about 30 seconds to think about this and write down anything you might say before I go through the answer. Okay, so this, where in the river's course would this image be taken? We are looking at a meander here. So as a result of this, this would be the middle course of our river. So this would be in our middle course of the river. Now, what could you identify in this photograph if you were asked to annotate it? Here at X, we have a river cliff, so you could have put your river cliff. On the opposite side, on the inside bend, we have deposition. So you could have said deposition, slip-off slope. You could identify here in the river that this would be the fastest current. You could identify that where our river cliff is formed, we have erosion. You could identify the flat land or the decreasing gradient around the river as well. So when annotating a diagram, what you're going to be looking for is details that you can add to the image that show your understanding of the geographical topic. Okay, so you would want to identify all of the different features, and you could add in those processes as well. So if you wanted to talk about that slip-off slope, over here you would talk about the deposition as well. Okay, let's look at another question. So once again, what course of the river would this be found in? What features could you possibly identify if you were asked to annotate this diagram? And what processes of erosion would be happening? So I want you to think about, once again, where you could see these different, where you could see the different processes happening and annotate the diagram. I'm going to give you about 30 seconds again to think about what you could put down for your answers. You don't need to write out the answer, but maybe just a bullet point of what you would include in your answer. Okay, so starting with question 1, what course of the river would this be found in? Because we've got a waterfall, that would be in the upper course of the river. Now, some of the features that you could identify in this picture, you could identify that we've got our more resistant rock with our less resistant rock underneath it, okay, because we know that we need to have those layers of rock in order to have the formation of a waterfall. We're starting to see the formation of a steep-sided gorge on either side. We've got our plunge pool at the bottom. You could identify the overhang, okay, and how the overhang is going to collapse. So all of these could be identified as part of the features in this diagram. Once again, when labeling, you're trying to show your understanding of geographical processes and what's happening. So you're trying to show that you understand that there's those layers of rock, okay, that we've got the overhang, that it will collapse, that we've got the creation of the plunge pool at the bottom, and now we have a gorge. So you're trying to show your understanding of the formation by labeling that image. And then what processes of erosion would be happening? You could identify that we would have abrasion, hydraulic action, the force of the water to create that plunge pool, abrasion, that sort of scraping sandpaper action as well. Let's take a look at a few more questions that we could potentially have for this topic. So describe how different river processes lead to the formation of one river landform that you have studied. So what I would like you to think about here is, first of all, what river landforms could you identify for this question? So what river landforms could you identify for this question? And then think about what processes would lead to the formation of that landform. Now, for this particular question, it states that you need to use an annotated diagram to help your answer. So remember, an annotated diagram is a descriptive diagram which with labels, which helps to identify different features. Okay, and I've put an example of a diagram here. So try and think of which formations could you think of first, and then identify which processes that you could identify. So I'm going to give you about 30 seconds to think of what you could potentially discuss here. Okay, probably the most common answers here would have been a waterfall. So people would have been thinking about the formation of a waterfall in that upper course of the river. You could have looked at the formation of a meander with the cross section, with the river cliff and the slip-off slope. You could have also looked at a levee. You could have identified a delta as well, but the most common ones that are going to be used here are waterfall, and probably the cross-section of a meander to identify those river processes. So if we looked at our cross-section of our slip-off slope of our meander here, we've got our river cliff being created by that erosion, okay, and we have that deposition then causing the slip-off slope to form. So there's a couple of different processes that are being used that form that river landform. Okay, so you're making sure that you're not only identifying the feature, but you are also identifying those processes that are leading to that formation. Okay, a few more questions. This is applying those geographical skills. So this is where we need to have our knowledge of our OS map skills. So this particular question is looking at the 4-figure grid reference for the river feature labeled Y in the photograph, and then identifying 2 river landforms that are shown in the photograph as well. So if we take a look at this image and we look at the 4-figure grid reference, so we're looking for Y. Okay, so we're looking for Y. So Y is within this grid square here. Okay, I always find it the easiest way to remember along the corridor and up the stairs. Okay, so we would go along the corridor and up the stairs. But it's also really, really important to remember that we're looking in that bottom left-hand corner. Okay, we're sticking to that bottom left-hand corner. Okay, if you always go to the bottom left-hand corner and go along the corridor and up the stairs, then you will always get the 4-figure grid reference that you need. So here, our along the corridor would be 89, and our up the stairs would be 71. So 89, 71 is the grid square we would be looking in here for a 4-figure grid reference. Okay, now in terms of our river landforms that we can see, you can identify a meander. Okay, we can identify a meander. We can also identify that we've got sort of our mouth of the river as well. Okay, so we can identify lots of different things, but remember along the corridor and up the stairs. This is another skills question that you might have on an assessment, and this looks at in what general direction does the Avon Conwy flow, or the River Conwy flow, and this time you need to give a 6-figure grid reference as well. So if we look at this image, we've got our River Avon here, sorry, our Avon Conwy here. Okay, now the direction that that is flowing, if you look at this map, that direction is a northerly direction, okay, a northerly direction. Now people often get really confused because they look at they see a river, okay, and they just go, oh, well, it's flowing south. But actually it's flowing in a northerly direction because we know that our river flows from the source to the mouth, and that our mouth is where our river meets the sea, okay? Now for 6-figure grid references, you do exactly the same as a 4-figure grid reference, but you're trying to be more specific in your answer. So you're trying to be more specific in your answer. So what we have is you find your 4-figure grid reference first. So we would have 27, 36, because once again, we're going along the corridor, up the stairs, and then we're in that bottom left-hand corner. So we have 27, 36. But we also need to divide our grid square, okay, into 100 smaller squares. And we do that by, you could draw lines down to divide it. I often find it easier just to divide it in half and know that's my 5, and divide it across and know that that's my 5, and then make dots from there, because I find it a bit easier to remember it that way. So if we looked here at our Thyn Grafnant, we would be 27, 1, 2, 3, 36, 1, or 36, 2, to identify that that feature with our 6-figure grid reference. Now, after we've looked at a couple of these exam questions, we're going to move on to the hydrological cycle. Now, the hydrological cycle is a more advanced term for our water cycle. So it's a more advanced term for our water cycle. And the water cycle is a continuous cycle showing the water's journey from the Earth's surface to the atmosphere and then back to the Earth. Okay, so we've got a cycle going. And it's also important to know that within this we have stores and we have flows. Now, stores are where it stays a liquid for a period of time. Where it stays in one form for a period of time. Where flows, it moves from one state to another. So, for example, when we have evaporation, okay, when we have evaporation, it's moving from our oceans up into our atmosphere. So that's a flow. Okay, and our flows are identified by our blue arrows. Okay, and our stores are identified by our yellow boxes. So the heating of the Earth's surface by the sun leads to evaporation of water. When the water vapor rises and cools, it then condenses to form clouds. Now, the wind blows the clouds from over the ocean or the body of water towards the land, and precipitation occurs when this water is released from the clouds. So it falls through the atmosphere and it enters into the drainage basin. Now, our precipitation can take on multiple forms. It can be rain, it can be hail, it can be sleet, it can be snow. Okay, but we've got our precipitation coming from our clouds that have condensed after being evaporated. On reaching the ground, some water will run over the surface straight into the rivers. Now we call this surface runoff or overland flow. Okay, so our overland flow. However, most of the water will trickle slowly into the soil. It will trickle slowly into the soil, and we call this infiltration. Some of this water will be stored in the soil, okay, and it will be taken up via plant roots. So as a result of photosynthesis by plants, water vapor will be released then through a process called transpiration. Some of the water is stored on the land surface, for example, in lakes and reservoirs, and it might be intercepted by plants and it could be evaporated back into the atmosphere. Water which reaches the bottom layer of soil starts to move through cracks and rocks and pours in the rock underneath. So we call this percolation. This means that water can enter a river channel in 3 different ways. So from the soil, from the rocks underneath, or directly from that overland flow. Once in the river, the water is carried out of the drainage basin and back to the sea as channel flow. The hydrological cycle can be impacted by both permeable and impermeable rock. So impermeable rock, such as sandstone, allows water to be absorbed into it, whereas impermeable rocks such as granite and slate do not allow water to go through them. So that can have a massive impact on the hydrological cycle. So let's take a look at a couple of questions that you might be asked on an exam paper about the hydrological cycle. So the first question is you may be given an image and you need to give the drainage basin process that's shown in the figure. So for this particular question, you need to choose either infiltration, overland flow, groundwater flow, or transpiration. So I'm going to give you just a few seconds to try and identify which one you think that might be. Okay, this picture would represent our overland flow, okay, because it's flowing through the, over the land. Next, we have an image that looks like this. You've got diagram 1.1. You need to identify what is a drainage basin and tick the correct definition below. And then you need to complete the following sentences using 4 terms from the box below. So you need to identify which word travels across saturated or impermeable land surfaces, which is the flow of water through rocks, which is the vertical movement of water into the soil, and which is the movement of water downhill through the soil. So I'm going to give you about 30 seconds to think about each of those definitions before I go through the answers. Okay, if we looked at what each of these four terms were, we have overland flow, which travels across saturated or permeable land surfaces. We have our through flow, is the flow of water through rocks. We have our infiltration, which is the vertical movement of water into the soil. And then we have our groundwater flow, is the movement of water downhill through the soil. So in looking at our different types, and looking at our hydrological cycle, sometimes we end up having rivers that flood. So in the UK, there are a number of reasons why a river floods, and flooding occurs when a river bursts its banks and overflows onto the surrounding land. So there are many factors which can cause a flood. Often the natural landscape can influence this, but we also have human interactions that increase our flood risk. So some of the factors that increase flood risk are prolonged rainfall. So if we get rain for a really, really long period of time, the land around the river can become saturated if it's holding as much water or moisture as can be absorbed. And so if that happens, the rain can't be then soaked up, so it runs along the surface, okay, and that's known as our overland flow. So one cause of flooding is just heavy or prolonged rain. Heavy rain is when there is less chance of it being soaked up by the soil because it's rained heavily over a short period of time. And as a result, it runs off into the river, and the faster the water reaches the river, the more likely it will be to flood. We also have our relief. If you have a steep valley, it's more likely to flood than a flatter valley because the rainfall will run into the river more. We also have geology. Permeable rocks allow water to pass through pores and cracks, whereas impermeable rocks do not. If a valley is made up of impermeable rocks, then there's a higher chance of flooding as there is an increase in that overland flow. We also have vegetation where trees and plants absorb water, and this is known as interception. So we have lots of vegetation reducing flood risk. Sometimes people cut down the trees, we call that deforestation, and deforestation increases the flood risk as well, as the water will not be intercepted and therefore will flow into the river. We also then have urban land use, and this is when an area surrounding a river is built on. So there is an increase in the amount of concrete, which is our impermeable surface. Drains and sewers take water directly to the river, which can increase our flood risk. So we can look at our river by looking at a river regime, and this describes the annual change in the amount of water flowing in a river. Okay, so this is showing the river regime of the River Severn. So there were certain times of the year where there is a higher discharge than there are other times of the year. So if we look at a number of questions, we have the catchment area of the Avon Conwy, and I want you to think about what the relief of the land is here in the catchment area of the Avon Conwy, and then suggest why villages in the Conwy Valley could be at risk of flooding. So what could you potentially identify in this question? I'm going to give you about 30 seconds to think about your answer again. Okay, if we were talking about the catchment area of the Avon Conwy, we would look that the relief is relatively steep, so that could increase that overland flow. If we were talking about why villages in the Conwy Valley are at risk of flooding, once again, we could talk about the relief of the land that we see. We could also talk about that it's relatively built up. Okay, and that being built up could create more impermeable surfaces, so therefore that could also increase flooding. You could talk about the geology as well, but what they would be looking for is that your understanding of why rivers flood. So the examiner would be looking at why rivers would flood and your understanding of that for this question. I'm aware and conscious of the time, so what I am going to do is go through very quickly management of rivers, and then we'll look at a couple questions that you might have for management of rivers, and that I will conclude the session. So with management of rivers, we have hard and soft engineering. Hard engineering is where we build artificial structures that are used to control our rivers, and soft engineering does not involve artificial structures. So it's a much more natural approach to managing potential river flooding. And if we're looking at our hard engineering strategies, we have things like dams and reservoirs. We have river straightening and dredging. We also then have advantages and disadvantages to each of these, and how and oftentimes hard engineering strategies are quite costly. We also have our soft engineering strategies. So this does not involve building artificial structures. So you might look at flood warnings and preparation, so preparing people that are at risk of flooding. You might look at floodplain zoning, which is where the land uses increase in value the further you get away from the river. So you're trying to avoid the area that would be flooded, so that you limit the risk of flooding in that area. Now, there are advantages and disadvantages to all of the different engineering strategies, but some questions you might want to consider. You might want to think about to what extent are hard management strategies effective. They could also potentially talk about, to what extent are soft management strategies effective. You would need to talk about the positives and negatives, or the advantages and disadvantages of each of these strategies. For a river management scheme you have studied, explain why it was required. So you might want to talk about, each school will have done their own case study. Boscastle is almost a commonly mentioned one, so you might want to talk about why that particular river management scheme was needed, what they did, and was it successful. You also could potentially get a question about hard engineering is better than soft engineering for managing flooding. Discuss. Now, for each of these questions, particularly the top one and the third one, you're looking at the advantages and disadvantages of each of these engineering strategies. So you want to talk a little bit about each of them to answer the question.